Good morning, Glenn.
Good evening, David.
Welcome to the World of FPGA Podcast. I'm your host, David Kirchner, and I will lead you through the world of FPGA. And now, let's begin. Well, welcome to our first episode of our FPGA Talk. Glenn, our co-host here, welcome here in this show on the FPGA World of FPGA Podcast. And today we just want to start a little bit who we are, where we come from, how we met, what was also very interesting, and what's our FPGA journey is. So, just warm welcome here, Glenn. I'm happy that you are here and that we do this together. It was a little bit, I was a little bit lonely here in this podcast, so now we have we are together here and can talk nerdy things about FPGAs. Yeah, welcome.
Perfect. Thank you, David. Looking forward to it and glad we could make something work out. It's been a journey, but here we are, so let's capitalize on it.
Yeah, okay. Well, maybe you start a little introduction, who you are, what's your journey to the FPGA, maybe?
Yeah, sure. So my name's Glenn Kirilow and I'm based in Melbourne, Australia, so the other side of the world, that crazy island in the south that does interesting things, that doesn't have good time zones with almost everyone. It has its advantages and disadvantages. So other than Australia, so I guess, how did I get into the FPGA? Well, that's an excellent question. And like probably everyone, you stumble into things in life sometimes. So for me, I studied a double degree at university. It was a Bachelor of Electronics Engineering and a Master of Microelectronics Engineering. And the microelectronics part is the FPGA and ASICs and analog integrated circuit design. So basically, I'd heard about FPGAs initially when I was younger because my dad also works in this line of work. He's a electronics technician of sorts. He was also an entrepreneur and has worn many hats over the years. He still wields a soldering iron today, but that's okay. So, I think when I was growing up, I would sort of hear him talking about things called gals and pals, and I didn't exactly know what they were. I knew that they were some sort of customizable digital logic of sorts. That was all I knew, and he would sort of tell me, these are really complicated things, and they're quite annoying because they're in this ball grid array package. And then so that was the first I heard of them when I was probably a teenager, I guess. And then at university, I remember I was in, I think it was first year, and I heard some second year students talking about these FPGA class. I thought, okay, that sounds curious. I knew about programming and microcontrollers because I had an interest from a younger age in programming. But as I went through university, I also had an interest in the analog side, and I was trying to find something that would kind of scratch both itches, both the visual. I'm a very visual person, so I like to look at schematics and layout, but I also enjoy the programming side too. And so when I took my first FPGA subject in second year, and it was very hands-on, it was all about, let's build a VGA driver, let's build a UART, let's build a, there were so many things. It was an SPI driver, high frequency. It was very hands-on, very full-on actually. Cool. It was VHDL. And I just remember the first lecture we had, the lecturer said, put your hands up if you've programmed before. And then he immediately said, you're all going to have a hard time because you're all going to think it's sequential when it's absolutely not. So he beat that drum loudly from day one, and I'm so glad he did. So I guess second year was my beginnings of that. And then in third year, I did more subjects. But when I knew it was where I was going to go permanently was in fourth year. When we built an FM radio from scratch using a Zynq, And this would have been in 2014, so in the early stages of the Zynq. I remember he said, this is going to be difficult, but it's going to be good for you, because he predicted that SoCs are going to be the big thing for the next decade. And boy, was he right. So yeah, I built an FM radio using a Zynq there. It was a 250 megahertz, 16-bit ADC coming off an FMC board, analog devices, ADC, and we did all of the digital demodulation in the FPGA, which then went to a speaker. And after about 3 months of struggling very hard, hearing crackles come out, I finally heard some audible audio.
That's cool. Yeah,
it was very cool, and it was Easter. I can remember the actual time it was. It was actually 10 years ago today. Actually, it was 2015. So probably today, I heard audio out of that radio for the first time 10 years ago. So yeah, that's FPGAs for me. I guess how I started with them, and then I tried to make a career out of it.
It started in your teenager times. That's impressive. Right. Yeah. Well, it's, on my side, it's nearly another way. My parents have worked as musicians, so my father was always interested in electronics, and I've learned a lot of electronics things, like building some circuits from the scratch, or analog things and digital components with breadboards and cables and really through-hole components, and solder them and get hurt a little bit on the
burn your fingers,
yeah. All the bad things. But it was okay. I learned a lot.
Part of the journey.
That's always part of the journey. If you never have got a problem with a hot iron,
you haven't lived.
Yeah, exactly. But the interesting thing is, on university, I've never learned something about FPGAs. So no thing. Okay, I've learned a little bit more about digital signal processing, or about medical electronics or electronic systems and other things. Very interesting. EMC stuff was also interesting, but not FPGAs. And when I was done, as I have my diploma, then in the first company I've come, it was Telefunken, the company who built the radio transmitters. So funny thing, I was on the transmitter side, you on the receiver side. So it's there we began to discuss and wanted to build up a new synthesizer for FM, for radio, and the idea was to use an FPGA, and this was the first time I've started to work with FPGAs with a Spartan 6.
When was that, David? What year was that, roughly?
2006, I guess.
Okay. Yep.
2005.
Almost 20 years ago.
Almost. Yeah, it's 20 years ago, I've got my diploma degree here.
In FPGA. No,
exactly not.
Introduction.
And then I started into it. Yeah, exactly. Yeah, I started to FPGA, and it was from this point. I cannot let my hand from it. So it was so interesting, and I worked with a Spartan 6 and with the CPLDs from Zynq. Yes. First with the schematic input. So
you're a brutalist.
Yeah. Later on, I learned VHDL. So from this,
you became sane. Yep.
Yeah. So it was very, very fun. So it's to create a transmitter with all the digital and analog parts, and in the FM, it's very difficult to get distortion freeness, and what was very hard. You need, what was it, 85 decibel spurious free.
Good luck.
You see everything here.
Yeah.
Nearly everything.
That's right.
So on the RF side, there was a traditional diode ring mixer. So with really high power to get at the output 25 milliwatts.
Oof. Okay. Yeah, that's pumping.
Yeah, well, it was an interesting time, and after that, I worked for different companies and also created my engineering office with the main reason to do FPGA development, also for other companies, not only for my for who I'm working for. Yeah, so that was my way, and today I have a podcast about FPGAs, as you know.
That's right. And here we are.
Welcome here.
That's right.
And one interesting thing here in Europe or in Germany is so I'm located in Berlin, in Germany. I haven't told this. Huh? So on the other side of the earth.
That's right.
We have the FPGA conference here. It's a really big conference about 3 days and 6 parallel paths, and it's every year in the July. And this year for the second time I have a talk there. So will be interesting to told other people things about FPGAs. This time I will talk about what was it? High-speed parallel connection to external devices and how to do this.
Okay.
And we'll talk a little about serializer, deserializer, and things like that. And, how to get some gigabits over parallel high-speed connections.
Wow. Okay, the simple stuff.
The really simple stuff that everybody would do here. Yeah.
That's right. We just do it for breakfast. We pour coffee and do high-speed serial links.
I do not think so. Yeah. Serial connections, but parallel connections, well.
Yeah, maybe not.
With 128 data lines, well.
Oof. Okay, you're properly in the world of the dark arts at that point.
Of course, yeah, with problems with ground bouncing and things like that.
Yeah, I know those all too well.
Yeah. So the funny thing is, we got in contact with my German podcast, when I remember correctly, some years ago.
That's correct. 2021 maybe, or 2020? Could have been one or the other. It's a while ago now.
Could be. I've taken a look into the archive, and we have talked 2 years ago.
Okay.
2 years ago about FPGAs, and was a funny episode.
Yeah, it was.
And now we're here. That's the idea. So, what will we do here in this in our FPGA talk?
I was just going to say. So you mentioned your first FPGA with the Spartan 6, right? Mine was the Spartan 3AN, actually, slightly older one. And I was using. Did you use Xilinx ISE with that as well?
Yeah, of course.
Yeah, it was ISE, that old crusty thing. Yeah.
I guess the start was the ISE 10 point something, and later it was this 14.7. That was the last one, I guess. The last version.
Right.
It doesn't run under Windows 11, only with a creepy patch. But
did you? Yeah, go ahead.
Yeah, I found a workaround, a very funny workaround. There is a Linux subsystem in Windows, the WSL2. Yep. And you can install the Linux version of the ISE 14.7 under WSL under Windows. And then you can use ISE. It works perfectly.
That's hilarious. I was going to say, what was your initial reaction to VHDL? Had you learned a programming language before? What was your VHDL journey? I always find this is a very interesting topic.
That's true. Well, I was pushed a little bit into cold water, I would say, because at the time I'm programming, or I'm building up this FM synthesizer. I come to a point where it's not really worked as I wanted to, and a lot of research, and didn't find the correct things. And then I decided together with my boss that maybe I need some help, and yeah, he was a cool boss. So that's
lucky.
He has always asked the right question to the right time.
Yeah.
And then you think, oh yeah, that's right. Yeah, and this was my first contact with PLC2. This is the biggest.
I know it. Yeah,
the biggest company here in Europe who are teaching FPGA stuff and helping also in designs. And well, I decided to book one person from this company for one day to come to me and sit.
Wow.
Sit in my office, and then we.
That's incredible.
That was the best decision I've ever made at this point.
Yeah, I can imagine. Who did you get? Who came?
I didn't remember the name. It's
okay.
Well,
that's okay.
I guess it was 2007.
Yeah, that would be scary if you did. But I'm guessing they were an expert, right? They're probably 20 years of experience with FPGAs, or.
Of course, he has a lot of knowledge, and we discussed a lot, and he showed me a lot of things, and we created some VHDL modules for my problems, and that was the starting point where I see, VHDL is also interesting, and I started to learn it, but I've never visited a seminar or things like that. Always reading a lot of things and trying a lot of things and discuss with colleagues. One colleague also was able to do things in VHDL.
Right.
And that was the starting point. But he used, I guess, was some CPLDs, so some easier things, so for controlling and things like that, but not for signal processing and not for high sophisticated things. So that was the starting point for me. And after that, I've redesigned the complete design in VHDL. So get rid of the schematics.
Yeah, that's right.
That was a very big step for me.
It would have been, yes. It's challenging.
But after that, it makes a lot of fun. It was quite easier. But I must say today I'm mostly using Vivado for my designs.
Yeah.
And I really love the block diagram things.
Me too.
Because it's like schematics in the electronic design. You have a top level design. You have all your blocks connected with thick lines and things like that. And if you go into one block, well, then you have your VHDL code or your IP core or things like that. And in the electronic development, you have your
schematic and PCB.
Yeah, the
data sheets.
The hierarchical block. So you can go deeper into your design and repeat things and things like that. So
do you use Altium over there, or do you use another PCB design tool?
I've used a lot of things, but today I'm at the OrCAD and Cadence Allegro world. So it's the classical OrCAD capture.
Yeah, you're one of the victims. Yeah,
yeah, and I must say I have to go to a training for 5 days for the Allegro PCB designer. Before that, I never know how to use it, but after the 5-day training, it was quite easy. So it was very important. This tool is so complex, and you can do the same thing in 3 or 5 ways. So over a menu, or you can use the mouse or the keyboard or things like that. And I'm using this software, but it's okay. It's
is it expensive as well? It must be expensive, right?
No,
for a license. No,
maybe 5,000-6,000 euros a year. Or
really?
for one license, and then what was it? 1.5 or 2,000 a year for the maintenance.
Oh, that's nothing. Altium's more expensive.
Yeah, it's okay. So it's not the complete Allegro. It's called OrCAD PCB. It's a small Allegro version. It's the Allegro.exe. So
I see.
It's the same software, but other
it's pretty
license.
lean.
Yeah.
Right.
But I like it. It's good to work with this software.
Did you know that Altium is from Australia?
No. Interesting.
Yes, Sydney. It was a Sydney company. It was a spin out from Protel, I think, in the early 2000s.
Hmm.
But I can't remember the exact date, but if you know Dave Jones, the EEV blog guy on YouTube, he's from Sydney. He worked for Altium when it was in Sydney headquarters. But I think now it's owned... I think there's a sales office still in Sydney, but America basically drives the company now. That's why it's got a lot of American marketing, but it used to be entirely owned in Australia until, I'm going to say, the mid-2000s, because when I was at university, we were all taught use Altium because it's Australian. Australian companies like backing Australians, stay in the system, don't get out. So, yeah, that's a fun little fact. Not many people know that Altium actually came from Australia.
Very interesting. Yeah. On university here in Germany, long time they were using Eagle.
Ah, yeah,
it was from FreeCAD, a German company, but now it's I think it's Autodesk or AutoCAD. So
right.
they bought it and integrated it, and then it has died for some years ago, or some months ago.
Yeah. There's a new web-based one at the moment from Germany I was evaluating. What was the name? If I remember the name.
PCB Software?
Yeah, it was PCB in the browser. It was actually quite amazing.
Okay.
Someone recommended me it, but then I got too busy with FPGAs. So
the important things here.
Yeah, that's exactly right. I filtered the noise out to get my signal to noise ratio better.
Yeah. It's always
but yes,
important.
interesting.
Yeah, some users are using KiCad, I guess, but
I'm using that too. Yeah,
I don't know if I'm working too much with Cadence. And
yeah, you're locked in.
So much funny things. So the connection to the database or connection to the SQL database for the components is nearly the best I've ever seen. It's worked since I don't know, 20 years, 30 years.
Wow.
And it's the only system I know where you can use, for example, you need a resistor and you type in 1K, and in the database it found 1000, 1K, and 0.001 meg. So it's it's analyzing the complete string, not only a comparison of the numbers. It knows what is kilo, what is mega, what is micro. So that's very interesting. And there is a company called Pulsonics. It's a combination from some engineers from Altium and from Cadence and from some other companies, and they said they built the new best and so on software.
Of course they did, yeah.
But this component information system can only doing some kind of text search. So if you put in 1000, it doesn't find a 1K.
Right.
That's not so nice. So that's a good thing in Cadence and in OrCAD. They're doing a lot of things right. Not everything. Some things are very strange. But,
strange and wonderful.
Strange, yeah.
Yeah. I was being kind with the last bit. That's a common Australian saying that's a bit tongue-in-cheek. Yeah.
Just learning a little bit Australia slang.
That's right. You're not just learning about FPGAs, folks. You're learning culture.
Oh. That's new to me.
I was gonna ask something interesting that came to mind is how much time do you spend on PCB layout and schematics versus VHDL and FPGA? Where does most of your time get spent in your day job these days?
Well, I'm also doing some embedded Linux stuff. Well, I guess 20% Linux, 40 schematics and PCB, and 40 FPGA. So things like that. So It's a good mix up. Okay, for my normal, I also have some things for my leading things. So I'm the head of electronic development, so I have to do other things also.
Okay.
But
So you have meetings.
when I can my other electronic stuff, then it's, I guess, 40-20 roundabout.
Interesting. That's an interesting point. I bring it up because so I get a lot of not a lot of young people, but I do see some young people at workplaces, and they ask me lots of questions about what do I do in my career. And when I say things about FPGAs, they get really curious. And one of the things I realize more and more as I do this, that it's not just like FPGAs is actually very multidisciplinary. I find that the best FPGA engineers have an appreciation of hardware, embedded software, FPGA, physics, and also the domain you're working at. So, for example, I'm working with lasers at the moment, so I need to understand some concepts about RF, light, radar, physics, EMC, but also the embedded software, the Windows software, the FPGA. Like, I find that the FPGA engineer is kind of the conductor almost in a company. They're kind of the conductor, if I can use a music analogy. And then they are kind of conducting all of these different domains to achieve a result. That's how I kind of think of it now, because, yeah, just talking to you, and as you said, you spend some time doing embedded Linux, the schematics layout, and the FPGA. I feel like through my line of work, I've mainly focused on the FPGA and embedded Linux boundaries, or the SoC boundaries, but I'm finding actually right now, at least at this stage of my career, I'm spending more time on the FPGA hardware / physics realm, where I'm looking at eye diagrams, I'm wondering about ground bounce, EMC, even horrible things. Actually, while I think of it, sorry, a bit of a tangent, but this will be good for listeners. What's the most crazy FPGA issue you've ever seen in your career? I've got a really good one that will shock people.
Oh, in my designs,
it could happen in production, an issue with the silicon, or a very strange EMC issue, something unexpected, vibration, thermal, power supply, anything.
Well, I found another funny thing. It's also nearly 18 years ago.
Okay.
There was a mask change in the Spartan 6, and
that's a good start. Yep.
And my design doesn't run anymore as I expected. So there was some timing changes, and I have to do a lot of search why the system which was in production doesn't work anymore. That was a big issue. So there was a mask change, and it had taken me, I guess, weeks to find this. Why it doesn't work anymore? It was the same chip. And then I see the three numbers there, and they were changed. Yeah.
Right. Oops.
And I have to do a new design for this. So to change some things in the software and things in the constraints. Yeah, that was, I guess, that was a stranger thing I've found. Yeah.
Okay, I've got a good one for you. Get ready for this one.
I'm just thinking, was it a Spartan 6 or was it a Spartan 3? Maybe it was a Spartan 3. I guess this was a 3. The 6 is the 6 comes later.
It did, yeah. I think the 6
comes
came
later.
out in
then what is a Spartan 3? So we have to start with the same component. Well,
yes, Spartan 3 came out, I think, in the 90s, technically. I'm just doing a Google search here. I find history interesting. So, Spartan 3. That's okay. I can't find the exact date, but I think it came out in the late 90s. But yeah, okay. So there was a mask change. So the issue I had, well, I wasn't directly involved, but I was in earshot, so I could hear people talking about it, was, so we were using a Zynq 7020, and basically we were really pushing this thing hard. We were using, I think, 90% utilization, which I've never seen any other company do. So we were really pushing it to its limits. And what we found is that it would take, I think, 6 hours to complete synthesis and place and route and bitstream, and it would fail 1 in 3 times. So we'd have to do like 18-hour builds to get a good build. Well, it gets even funnier. When we did that and we got a quote-unquote working bitstream, we would occasionally notice that we were killing FPGAs. I'm like, what? We actually were blowing them up. And we're just like, what the hell is going on? And so we were on calls with San Jose, the headquarters of Xilinx, for, I think, months, trying to work out this issue. And this is the most incredible part. I was telling this at work the other day, and they just couldn't believe it. I still can't believe this, that what they actually found was in the VHDL code we had, there was some debug logic that just kind of had some, I guess, stray taps that we used to chip scope or something like this. Mm-hmm. And what was happening is we were actually vaporizing traces within the FPGA die.
No.
And yeah, that's right. They saw it with a 3D X-ray machine in San Jose, and they worked out the exact track in the 3D space. And it was 100% reproducible. It was always the same spot. And I don't think they ever told us exactly what the reason is, but they said, look, just remove that debug logic from your build and it'll fix it. And it never happened ever again, but I suspect it was a capacitive load issue where we were possibly driving a trace too high. And it makes sense, right? If you're using 90% utilization, then you're already really pushing the currents very, very high. So you're probably just vaporizing traces. But that's the most amazing thing I've ever heard.
Of course, yeah.
Yeah.
So Spartan 3 was introduced in 2003.
Oh, really?
Yeah.
It's when did the Spartan 6 come out? Was that 2006? Possibly.
Well, maybe.
That would be funny. Spartan 6, 2006.
Yeah, but I don't think so.
No, I don't think so.
Last year there was an interesting talk at the FPGA conference exactly about this how to draw at most current as possible in what was it, the AWS from Amazon. There you can also use FPGA boards.
Yep.
And there was a professor of the university in well, I don't know. It's I think it was in Karlsruhe, and he did some research how to draw as much current as possible with some designs, and it was some kind of ring oscillator, and they get it up to 6 gigahertz.
Wow. Okay.
And then they connected a bunch of flip-flops.
What could possibly go wrong?
And it only worked for some seconds. And then the thermal shutdown came from Amazon, and the board was off. But there was calculating some 1,000 watts they could draw from the power supply maybe, but it's stopped at the right time. Wow. Nothing gets damaged, but it was a very, very funny talk he held there.
Right. There was another funny issue I saw on I've seen a few funny things on a Zynq 7000. So you know how with a Zynq 7000 you've got a 1.8 volt rail or a voltage going into the FPGA. Well, one company made an oscillator, a positive feedback loop oscillator on that input because of parasitic inductance between the switch mode 1V8 power supply and the parasitic inductance of the board created a positive feedback loop. And so in your Bodhi plot, it wasn't, it didn't have marginal stability in the phase. It was, there was no stability.
Oh, okay.
That took them a very long time to find. I've never actually seen someone use a Bodhi plot with the phase plot like that to work out issues like that. So that was interesting. I was impressive that they worked it out so fast, actually.
Power supply is always something you have to look at, especially if you're using a lot of IOs and
correct.
There's something not working so okay, then
yeah, it doesn't look like a simple resistor, unfortunately. If only it did.
Yeah. So, well, I think we have talked enough.
Yeah, I think so.
Most people have switched off now.
That's right, yeah, including us.
We're also switching off now. Yeah,
that's
then
right. Yeah.
I would say we will talk on another morning/evening. Yep. And then I would say have a nice day today. And
thanks, David.
That
was fun.
We will talk again. See you later.
Sounds good. See you, David.
If you found this episode helpful, please rate it on Apple Podcasts and share it with your colleagues and friends. That's the end of today's podcast episode. Thank you for listening and for your attention. So I say goodbye here next time, your David Kirchner.